Hey everybody, welcome to the Chapter 6 review. Sorry I'm not there with you today. Remember that you can pause this at any time to write stuff down and then listen to me talk, which is what I would suggest. Okay, so we started off the chapter with kind of this spinner situation. We had this spinner at 2, 3, and 5, I think, and they each had different probabilities. We made those into a table like this, and the first thing we decided was, what is a valid probability model? That will come from either a table or a spinner, and the spinner we usually make into a table. All the probabilities listed will need to be between 0 and 1, and they all need to add to 1 for it to be a valid probability model. The second thing we did was we found the expected value, or the mean, of that probability model. And so what that means is like what you would expect for each spin, basically. And we said the expected value and the mean are equal. Here's the formula. So x times p of x. And I say top times the bottom plus the top times the bottom. So top times the bottom plus the top times the bottom plus the top times the bottom. If you're too lazy to do that by hand, or you have the whole table and don't need to do it by hand, you put your x's into L1, your p of x's, your probabilities, into L2, and do one variable stats L1, L2. X bar in that is the mean and the expected value, both are the same. Sigma is your standard deviation, and then you have to square that to get the variance. Note, no need for binomial or geometric if you have a table. So you guys are going to notice this on the team test. I think their very first question, I actually don't know if it's the first question, but I was remembering this from last year. A lot of students would have a table like this and then they'd start to jump into binomial and geometric, which is fine, but not all of these are binomial and geometric. And why do that if you actually have the numbers in the table already? So just stick to this if you have the availability of a table. Okay, then our next topic was transformations of random variables. And what we noticed was that if you multiply or divide by a constant, so this is one spin where you're doubling your amount, one spin where you're tripling your amount, one trial multiplying the outcome, you multiply or divide both the mean and standard deviation by the constant. So this would get 2 times more spread out and 3 times more spread out. Also 2 times higher of a mean, 3 times higher of a mean. However, if you're adding or subtracting a constant, something like x plus 4 or x minus 1, that is one trial adding or subtracting something to the outcome. And you add or subtract the constant to the mean only, or measures of position, but not the standard deviation and not the variance. They don't get more spread out. They don't get plus 4 more spread out or minus 1 more spread out. Remember, those were just a shift up and down the x-axis. And then here is an example. So I gave you a mean and a standard deviation, and I gave you a linear transformation. Notice the mean gets everything, so 3 times 2 minus 4, but the standard deviation only gets the multiplication. Okay. The next thing we looked at in the chapter was combining random variables with addition or subtraction. So the difference here is now you have 2 separate spins of the spinner, and then the outcomes are added or subtracted, which means that your outcomes are much more spread out, or the possibility of your outcomes are more spread out. Remember, we did those kind of 9 boxes, which showed you had actually 9 different possibilities instead of 3. In that case, the mean is just the 2 means added together. The variances are just the 2 variances added together. However, the standard deviation you cannot add. Do not ever add standard deviations. What you need to do is convert them to variances, then add them, then square root them to get them back to standard deviations. Okay, the trick for subtraction, if you remember, the mean was actually subtraction of the means. The variance and standard deviation, though, ended up being exactly the same as when we added. So you don't ever subtract variances or standard deviations. Remember, this had as many outcomes. Still had 9 outcomes, which was more spread out. It doesn't get to be less number of or less spread of outcomes. So you're always adding here no matter what. So put a little star there or something to help you remember. Always plus here, and then for this, never add standard deviations. Always convert them to variances and then add them and then square root to get back to standard deviation. Okay, our next section was very kind of big, and so you're probably going to pause me for a minute here, but that was binomial distribution. And binomial distribution is very specific. It has 4 requirements: fixed number of trials, equal probability for each trial, equal probability of success, I should say, for each trial, independence, and a success or failure situation. And so I have written these as little formulas basically, and I have big X, which is your random variable notation, and then little x is what I'm going to plug in. And this is the number of trials, n, p is the probability of success, and x is the number of trials that you're interested in having success. And binomial requires 3 numbers, 3 inputs. So you have number of trials, probability, and then what you're interested in. And then remember, we've got all these different situations with different inequality symbols. So less than or equal to is what the calculator is already going to do, so that's just typed straight in. Greater than is 1 minus. Less than is taking 1 away from the one you're interested in. And then greater than or equal to has both. And then when you're between 2 numbers, you have the second one, and then the first one, subtraction of the first one minus 1. If you want to go back and look at those, I believe those are in 6-52 to 58 if you want numeric examples, but I think these are also great and all really nice to have right next to each other. And then in the next part of binomial, we talked about the describing the distribution, so center, spread, and shape. The center of a binomial is n times p, so number of trials times probability of success. Standard deviation is the square root of n times p times 1 minus p. And the shape, you're checking to see if it's skewed or normal enough. And to check if it's normally enough, you have to have both of these 2 formulas be true. And if they're both true, that means that it lied on the pickle, so it was on the shaded area of the graph, and you could use normal CDF as an estimate. However, remember, you're looking at something discrete, which is binomial, and going to continuous, which is a curve, so you might have need for some kind of continuity correction there. Most of the time we won't use this unless we're asked to use a normal approximation. But you can if this works out. Okay. And our last topic, which was Thursday, is geometric distribution. There are 4 requirements again, and there's not a fixed number of trials. You're looking for trials until your first success or failure, depending on the wording. And you can kind of tell a geometric problem because it'll have the word first in it a lot of times. So just hunt for that word, and then you can open to your geometric notes and follow those. Equal probability on each trial is still necessary, independence is still necessary, and success or failure situation is still necessary. Okay, geometric PDF is only requires 2 numbers. You have a probability, and then where your first success or failure will happen. So if you have failure here, you want first failure. If you have success here, you want your first success. And it only requires 2 numbers to plug in. So Another thing you can look at in the problem if you're having trouble identifying binomial versus geometric, does it give you 2 numbers or does it give you 3 numbers? If you're only given 2 numbers, likely it's going to have the word first in it or something to do with the first success or first failure, and you're going to be in geometric land. Less than or equal to is geomet CDF, and then it follows the same rules as binomial for these different inequality symbols. And the center is 1 over p. If you guys remember my silly cereal story, like if there's 6 different toys in the cereal boxes and the probability of getting each toy would be 1/6, so 1 over 1/6 would be 6. So then you would expect on average to have to buy 6 boxes of cereal to get the one you wanted, which is always working. Always working. And then here's the spread, and I don't have a fun story for you there. I just know that that's it. And the shape of geometric is always going to be skewed. I want you guys to think in your mind about a geometric sequence, and it's an exponential graph. So that's clearly going to be curved and clearly going to be skewed because it starts out with a lot and then kind of trickles off. And that is it, you guys. That is my chapter 6 review. And after this, your homework is to do 2 AP Classroom progress checks, Unit 4 B and C. And some of this, we'll cover all of this chapter. The first few questions of Unit B, of progress check B, are going to be something we did previously, but it will very quickly get into chapter 6. And thank you, everybody. Have a great day. I'll see you tomorrow on Tuesday. Bye.